Assalamu alaikum everyone, welcome back to Developer Maroof. In today's lesson, we'll learn about performance tips, how to measure code speed, and 3 important techniques every JavaScript developer should know, like debouncing, throttling, and memoization. So let's start coding. So before starting anything, let me tell you why performance matters. So in JavaScript, when we call functions, like a function called once is fine, no matter how slow. And if the same function called 1,000 times in a loop, or on every keystroke, or on every scroll event, that's where performance start to bite. Today we measure code with Performance.now method, and we learn 3 patterns to control how often expensive functions runs. So we will run all our code in the terminal with node. After each section, save the file and run node script.js to see the output. So let me write some performance code, how we can measure the performance, and I'll have you understand what this code do. So let's add a comment, measuring performance. Let's create a start variable equals performance.now, and this is a method. And then we will create another variable, sum equals 0. Then we create a loop, let I equals 0, semicolon, then I less than, let's say 0, 0, 0, 0. Type any number you want, I plus plus. Now inside that we can just do sum plus equals I, and then we can see what end performance is. Let's say performance.now method, and then we come here, we add a log and backticks. Let's say loop took end minus start dot fixed 2 milliseconds. Now save it, and let me tell you what this code do. So performance.now gives a high precision timestamp in milliseconds. We capture it before the loop, and we again capture it after the loop right here. Then we subtract. So the result will tell me exactly how long a million addition this one takes on this machine, probably a few milliseconds. So you will come inside the terminal and run node script.js. But first, let's come into this directory. It's lesson 5. So now we say node script.js and hit enter. So you see the result is loop took 16.61 milliseconds. So this is how you can measure the performance. So this was a first technique, how you can measure the performance. Now let me show you another way to compare 2 approaches. Like, let me tell you the difference. Let's add a comment, compare for loop versus reduce. So let's create a variable, numbers equals array dot from. Then inside this we will have a length, let's say it's 100,000, then comma underscore comma I, then it's a callback I. So come here and const t1 equals performance.now, and then we can create a total 1 equals 0, and then for loop inside that let I equals 0, semicolon, I less than numbers dot length, then I plus plus. And inside this we can just do the same, total 1 plus equals numbers I, and after this let's add a log. So for loop, let's say performance.now method minus t1 and dot fixed 2 milliseconds. And then we will have a reduce method. So let's say const t2 equals performance.now, and then again we const total 2 equals numbers are reduce. So in reduce, you know, we have an accumulator and n, and then we have accumulator plus n comma 0. So right here let's add a log, backticks reduce. So reduce will take performance.now minus t2 dot to fixed and 2, and these are milliseconds. So let's save. So these both will give us the same results, but these are 2 different ways to measure the performance. This is a classical loop, and this is an array reduce method. Now we can compare them with hard numbers. So for loops are usually a bit faster because they have less overhead, but the difference is tiny. Use whichever is more readable, unless this code is in a hot path that runs thousands of times. So let me run the script and see the results. You see, loop takes 1.23, which is a bit faster than reduce, which is taking 2.86 milliseconds. So these both are the ways to measure performance. Now let me show you another way, which is debouncing. So let's comment these out and let's come here. So before starting, let me tell you something about debouncing. What is it and why we use this? So basically, debouncing delays a function call until the user stops doing something for a set time. So the classic use case of this debouncing is a search box. You don't want to fire an API request on every single keystroke. You wait until they stop typing for half a second, then search. Let me write some code and I'll let you understand how it works. So let's create a function. Let's name it debounce, and this function will take a function as a parameter and a delay. And inside this, we will have a timer, and then we will return a function which has arguments. And inside this, we will clear timeout. We will pass the timer here. Then we will call timer equals to set timeout. Then it will take a callback function. And inside this, we will say function. And inside we have the arguments. And then we have a delay. So debounce takes any function plus a delay and return a wrapped version of it. Each time the wrapped function is called, it clears the previous timer and starts a new one. The original function only fires once. The calls stop coming for the delay period. So let's test it so you understand better what I mean by this. So let's create a variable search equals query and add a log here. Then we can add searching and query. So whatever we search, it will print inside the log. So another variable debounce, or debounced search equals debounce search, comma 500 delay. So you see, this is the debounce search, and this is the function we created right here, and we passed a search function because search is equals to this function, and we passed that as an argument, and it will take it from here, and we pass the delay, which is right here. And now we will just invoke that function. Let's say debounced search. Let's pass any query. Let's say h. Then let's copy it below. So just copy it from here and paste it a few more times. And let's say hey, hello. Let's say hello. So we did 4 rapid calls. But if we look at the output, let's say script.js. Okay, if you look at the output, only one search happens for hello, this one. The first 3 got cancelled because new call came in too fast. That's debouncing. Imagine skipping 3 useless API requests every time the user types a word. So I hope you understood this debouncing concept. Let me just comment it out and let's see what is throttling. Let's add a comment, throttling. So before starting, let me tell you about throttling. So throttling is similar but different than the debouncing. Instead of waiting for a pause, throttling limits how often a function can fire, like run this scroll handler at most once per second, no matter how fast they scroll, or update this card at most once every 200 milliseconds, no matter how many data events arrives. So let me write some code to let you understand better. Let's create a function throttle, and it will take the same way a function, but it will take a limit, not the delay. Debouncing takes the delay. Throttling takes limit. Now let's create a variable let waiting equals false. Then we will return a function, and same way it will take arguments. Or inside that we will put a condition. If no waiting is false, then function will take arguments, and waiting will be equals to true, and set timeout will be waiting equals false, and we will have a limit here. So throttle uses a waiting flag. When the function is called, if we are not currently waiting, we run immediately and starts a timer. While the timer is running, additional calls get ignored. once the timer ends, we accept the call again. Let me show you by testing it. So let's create a variable on scroll. On scroll equals a function which will log, let's say, scroll at, then let's put a date here, and then let's say scroll or const throttle scroll equals throttle on scroll will be a function, and the limit will be 1 second. And now we should call that throttle scroll right here, and let's paste it right here, and let's put a log here. Only the first call ran, the rest were throttled. So 3 rapid calls, only 1 line will be printed for logs. Let me say, okay, you see scrolled at this and our console. So this is how throttle works. We use debouncing for search boxes where you want to wait for a pause, and throttle for scroll and resize events where you want a steady rate. So I hope you understood the concept of throttling. And now let me tell you the final concept, which is memoization. I have told you that before in our previous lessons, but let me just quickly remind you that in here as well. Memoization. So basically memoization means caching the result of a function. If the same arguments come in again, return the cached answer instead of computing it again. This is a huge for expensive pure functions. So let me write a function memoize, then a function, and curly braces, const cache, empty bracket, return function, then our arguments, then we will have const key equals JSON dot stringify and arguments, and if key in cache, then we just simply log from cache, and we will just return that cached key. If it doesn't exist, just say const result equals function arguments, then cache that key, the result, then return that result. Let's save this. So memoize stores result in a plain object, this one, using JSON of the argument as the key. On every call, we'll check cache. If we have seen these arguments, we will return that instantly. Otherwise, compute, then cache, then return. So this is the flow, how we use memoize. So let me quickly test it so you understand better. Save it. So let's create a variable. Let's name it Fibonacci. Basically, he's an Italian mathematician. So Fibonacci equals memoize function, and inside that we have a number. Then if n is less than or equals to 1, then we will just return that number. If not, then we will return Fibonacci n minus 1 plus Fibonacci 10, not 10, maybe n minus 2. And now let's add some logs. Let's say 5a 10, that's 10. Let's add a column, then Fibonacci 10, then let's just copy it and paste it right here, and let's again, and then let's make it 20 and 20. So if we run this, you will see, okay, we did some mistake here. So we have, okay, we just made a mistake here, which is not a function. It will be long array. Okay, just save it and then run it again. Okay, you will see we have the results. So look at this. Without memoization, Fibonacci of 40 makes billions of recursive calls because it recomputes the same sub-problems over and over. With memoize, each value gets computed exactly once. The second call to 10, we have this. 10 prints from cache and return instantly. You see, we have nothing in cache, and it calls 3, 3, 6, 7, and 9 times, then returns our first call, then it saves in the cache, so the second call comes right from the cache, and then again our third call, and it is cached. So if we call it again, you will see, if if we call it again, copy this, paste it here, and let's say again and run it, you see we just got that right here. So basically memoization turns an algorithm that runs for hours into one that runs in milliseconds. Use it for any expensive pure functions. So that's it for today's lesson. You just learned performance tips, mirroring with Performance.now, debouncing for search inputs, and throttling for scroll events, and memoization for caching expensive computations. So in the next lesson, we'll learn about DOM observers, mutation observers, and intersection observers. If this helped you, like the video, subscribe, and share it with someone learning JavaScript. Jazakallah khair for watching. Allah Hafiz.